Well, here's a project that I've been wanting to work on for several years now. It is to turn some dumb speakers into smart speakers. I actually started this, or tried to start this project before the spicy cough, to be honest. That's how long it's been. And I just never got anywhere with it. But anywho, that's what I want to start working on today. This is going to be part one of my smart speaker build. And today I'm going to build the amplifier. So you're probably thinking, what kind of amplifier am I going to build? Well, many years ago, here in Australia, Ultronics and I also think Jaycar used to sell these little kit 20 watt, 12 volt amplifiers. They were easy to assemble. I mean, they're all through-hole soldering, and they actually gave a pretty clear sound. So probably back in 2018, I bought one of those kits because I was bored and decided that I would put it together. And I did. And then I thought, you know what I want to do? I want to mount it inside a speaker. So I tried to do that. The speaker wasn't anywhere near easy enough to get apart. So I kind of broke it in the process, and then I accidentally shorted out the amp in the process and broke that. So yeah, anywho, then spicy cough happened and I just never got around to it again. But I did start planning for this video late last year by buying some of these little silicon chip boards. So these are the same boards. In fact, I actually think these are slightly more modernized. I'll tell you why in a sec. But they're basically the same board that was sold by Ultronics and Jaycar here in Australia in a kit form with the capacitors and all the other components that are required to assemble these. There is one slight difference. The older boards did require a couple of connecting wires over the top because they were a single-sided PCB. They have actually resolved that issue by making it a double-sided PCB. But that doesn't really matter. It's not a huge change. Anyway, Silicon Chip Magazine still actually sells these bad boys online, and they are about $7.50 at the time of this video. So I thought I would buy a few of them and put them together. The problem is, you then need to find the copy of Silicon Chip Magazine, which I think was May 2010, if anyone wants it, or when anyone wants to look for it, that has the assembly instructions for this board, because that has all of the parts that you need for this board. But it wouldn't be that easy. It has all the values for the capacitors, the little amplifier chip, the op amp, the variable resistors, capacitors, all of that wonderful stuff. And in fact, all those values are sitting here on the board as well. So you could, in theory, just, have a look at them. For the capacitors, it also has the chemistry of those capacitors. So whether they're electrolytic, ceramic, leaky, whatever kind of capacitor that is needed. But it doesn't have any of the sizing on the pages. So you don't know what sort of lead spacing that you need, what sort of size that you need, what sort of diameter that you need. You sort of basically need to get out your clamp meter and measure the board. So I did. And to make everyone else's lives easier, I've gone on to Digikey and I've created a parts list for this particular board, which I will put in a link in the description. Noting on that, there are a couple of capacitors that I wasn't able to get the correct lead spacing for. It just seems like the ones that they require for this are very odd. Doesn't matter, the ones that I have selected do fit, they're just slightly narrower than what's recommended, but I digress. I've put together the parts list so you don't have to do the running around. I have used decent quality capacitors in all of this, so I think the ones, I wouldn't say that they're the least reliable. I would just say that they're the most unknown are a few ceramic caps by TDK. I don't have a problem with TDK caps. I don't know if anyone else does. I just don't see them rated anywhere. But they're Rubicon, Nichicon, or Panasonic for everything else. The only parts that I couldn't get were the variable resistors because they use some special crap that only Ultronics and Jaycar seem to sell for some reason. The other thing to note on my list, if you do decide to go off that list, is I bought a slightly upgraded Amplifier chip. They are pin compatible. They are mostly the same specification. It's just the one that I chose has the ability to take a slightly higher input voltage, and that will give you a slightly higher speaker wattage, and it doesn't seem to otherwise affect the board in any way. So yeah, oops. But yes, now that I've gotten all that out of the way, majority of the parts are available from Digikey on the list in the description. The other parts that you will need, which are mainly headers, the variable resistors, and heatsink, of course. I just went to my local Jaycar to collect them, but you could go to Ultronics or Jaycar, or if you don't live in Australia, wherever you get your electronics from. Otherwise, yes, this is just a part available on the Silicon Chip website. It is kind of hard to find. I will also put the part number in the description because Silicon Chip magazine probably needs to make their website a little more user-friendly because it basically hasn't changed since, I don't know, the late 90s, maybe. But anywho, the fact that they're still available is pretty awesome. What I want to do today is I want to build this. I want to get it working, test it out, and go from there. So let's get to the bench and get this built. We've got our PCB from Silicon Chip magazine here. Alright, now package from Digikey. Let's get everything out. Oh, my favourite, individually packaged parts. Yay. So good for the environment. Let's start off with the 470 nanofarad film capacitors. Next up we have our 1 nanofarad capacitor and two 47 nanofarad capacitors. These are electrolytic. Now don't forget, these are polarized capacitors. Make sure that you check the polarity of the capacitor against what's on the board, otherwise they may go pop. Now I'm going to put the big boys on. So there are 4 2200 nanofarad capacitors that need to go up the top here. Again, these are polarized, so just keep an eye out. Now for the 100 kilo ohm resistors, there are a few over the board, so you'll find 2 of them to the right of the board in a little area where there is 5 resistors. You'll find 1 just to the left of that. You'll find 1 just next to the variable A10K resistor points, and there is 1 more just above the power input. Let's get soldering. Well, there's the first fuck up of the day. I accidentally put a 47 nanofarad in where the 100 nanofarad is supposed to go, so I better switch those over before I blow something up. Well, at least that crisis was averted. Now we have some 4.7 microfarad non-polarized capacitors to put on. There are 4 of them. Now, if you did an order from Digikey based on my little template that I put in the description, you will notice that these ones don't have the correct lead spacing. At the time, I wasn't able to find anything with the correct lead spacing or the correct diameter, so these were as close as that I could get. But hey, I managed to get them to fit, and you should too. There are now 8 22 kilo ohm resistors to put on the board, and they are all over the shop, so keep a good eye on them when you put them in. Now onto the 4.7 kilo ohm resistors. So there are 4 of these, and they are all located above VR3, the B50K variable resistor. Now to do the 10 kilo ohm resistors, not to be confused with the 1 kilo ohm resistors or the 10 ohm resistors. So there are 4 10 kilo ohm resistors to do on this board. And once again, I put a couple of the parts in the wrong place. Better go fix that. Now onto the 2 1 kilo ohm resistors. Now to move on to the 10 ohm resistors. There are 4 of these to install. 2 of them are sitting just below the 470 nanofarad film capacitors. The other 2 are in that block of 5 on the far right of the board. I'm going to put in the dip socket now. Now when I do this, I'm going to solder one of the legs first, and then I'm going to try and make sure this dip socket is sitting nice and flat by holding the soldering iron against that pin while squeezing it downwards. I'll then solder a pin on the opposite side of the dip socket and do the same thing just to make sure that it is sitting nice and flat and is nice and secure. Then I will do the rest of the pins. Alrighty, that dip socket is nice and flat and ready to take the little op amp. Next up are the two Zener diodes. Now, both of these Zener diodes are on the left near the power input. A couple of things to consider. First off, they are polarized, so make sure you do put them in the right direction. Second off, the ones that I selected on the Digikey order, the leads are slightly thicker than probably what was expected, so they may take a little bit of force to get them into the hole. So just be careful of that. And the last thing to remember is they are sitting awfully close to that power connector. Make sure you leave a tiny bit of room for a power header to be soldered to the board, otherwise you might have a bit of hard time later getting that header on there. Otherwise, let's go. Just going to whack the last two non-polarized capacitors on there. Next up is the MOSFET. Now, when putting this in, keep in mind that you do need to bend it sideways in order to line it up with the screw hole that goes through the board. You will also want to put a screw in there just to hold the MOSFET down. But yeah, when soldering those legs, just be wary that you will need to or be able to bend it, and you will need to be able to align it with that hole. Now to put in the two 10 picofarad ceramic caps. Both of these are in the middle of the board towards the bottom, so right next to the B50K variable resistor. The other one is just above that. Now to whack the 100 nanofarad film capacitor just above where the dip socket is. Make sure you get the right holes because there are some vias just next to it. Although looking at it, it probably doesn't really matter which holes that you get. So yeah, just be wary of that. And then the two 10 nanofarad film capacitors. They're just lodged in between a whole bunch of 22K resistors. And completing the circle of film capacitors, we have 4.7 nanofarad capacitors, 4 of them, to go well above the 4.7 kilo ohm resistors. Now we move on to the big boy. Time to put on the TDA 7379V amplifier module. This one's easy, it can only go in one way, so I'll solder the first pin, make sure it's nice and straight, solder a pin opposite, and line everything up, and then I'm going to solder the remaining pins. Now let's get this one done. And now to squeeze the op amp into its little socket, making sure that we get it around the right way so we don't blow anything up. And we also got to make sure the pins are bent in the right direction. So I've now got the variable resistors to do. We need 3 of them here. So we have the B1000K, B50K, and an A10K. Now I ended up getting all of these from Jaycar because I couldn't find ones that fit at Digikey. But if you do find one at Digikey that fits and want me to add it to my little list, feel free to put in a comment on this video and I will be happy to have a look at it and put it into the list. Anyway, the way that I'm going to do this is the same way that I did the socket and the amp itself. I'm going to solder the first pin, I'm then going to heat that up and make sure it sits nice and level. Then I'm going to solder the opposite pin and I'm going to do the same again. I will do this for all 3 of these variable resistors. Let's get them on. So you need to run a bare wire over the top of the variable resistors. There are holes in the board for this already, so just solder it from one side, run over the variable resistors straight to the other side. Then what you need to do is you need to put big blobs of solder on top of the metal casing of those variable resistors, just so that they can be grounded together. Now, if you're using a metal case, the metal case will be your grounding point, but if you're going to put this in a plastic or a non-conductive case, you will need to ground those wires. There is a little header for grounding them, and you will then ground it on to the negative plane of the power supply. So just keep that in mind when building this, otherwise you may get a bit of noise through the amp. If you are using a metal case and using metal lugs to connect the device to the case, then you won't use this grounding method because that may also create extra noise. So just be mindful. Now there is a switch button to softly turn on and off this amplifier. I'm not going to use it, so what I'm going to do is I'm just going to put a jumper wire there. If you prefer though and would like that switch operable, then what you should do is connect either a header there so you can put in a switch or some wires to directly connect the switch. But as I said, in this case I'm not going to be using it, so I am just going to jump it together so the amplifier stays on at all times while it's powered. The last thing to solder on is the little terminal connectors. Originally I wasn't going to use these, I was just going to solder the cables directly onto the board, but I decided that maybe I should use these terminal block connectors. I did solder the audio input cable directly to the board though and left that there. Now you can solder these on top or on the bottom, it doesn't really matter. It does have plating on the holes on both sides. And that's everything soldered up to the board. Now it's time to test it. So I thought I'd give you a bit more background. Why did I choose to use a do-it-yourself silicon chip amplifier? I've just used it before and I quite liked it, and the sound that came out of it was very good. You can get different kits. I'm sure if you look on everyone's favourite PCB website, you could probably find some different designs as well and get them printed. Core Electronics and places like that do seem to sell some even smaller 20-watt stereo amplifiers as well. I do actually have a couple of them. I don't think they sound all that crash hot, and yeah, I just didn't like them as much. So the reason I chose this one was, well, one, it was something that I could build myself. Two, output's really great sound. And three, which is probably the most important part of this, is that it uses a DC power pack or a battery if you wanted to. It can run off 12 volts. Rather than having to supply your own transformer and everything like that. So everything's relatively compact on a single board. I can then get an external DC power brick or a wall wart or whatever I want and plug this board into it. And if I wanted to make this portable, then I could in theory get a lithium or a lead acid battery. I don't know why I'd get a lead acid battery, but whatever. I could get a battery and turn it into a portable speaker. Anyway, now that we've got it assembled, we've got to do the important part and see if the magic smoke escapes or see if we manage to contain it. So let's go take a look. Well, that's some good news. The amp didn't go pop. It means everything has been soldered on correctly. Now, you may have noticed while we were testing that I've only got a itty bitty teeny weeny little heatsink on it. I'm only using that heatsink for testing. You do need something a little bit bigger than what I've put on there because boy does this thing produce a lot of heat. I will put in a link in the description, the heatsink that was recommended by Silicon Chip magazine back in the day. It is still very much available from your favourite little electronics duopoly. So I suggest getting one of those and doing it properly. But today we're just getting the board ready to work. So let's see if I can then connect this up to a couple of speakers and make sound come out. So I am going to go find some space and do that now. fantastic. It produces sound. So I'm very happy with that. I've now got an amplifier board that works, produces sound, and doesn't go pop. Now, as you can see by the fact that I've been fiddling with this, I didn't just buy the one of them, I actually bought 3. I also bought enough components from Digikey to build a second one of these. So I don't know what I'm going to do with the second one yet, but I will eventually build that. So great news, the amplifier is working. So the next part of this is to build up the smart part of the smart speaker. So what I want to do is I want to probably get something like a Raspberry Pi, you know, if you can actually get hold of a Raspberry Pi at the moment. Install some smart speaker software on there and connect it through to the amplifier and have it running that way. Don't know which software I'm going to use just yet. I have looked at a couple. Unfortunately, the only Raspberry Pis that I have around at the moment are some 0Ws, which are not powerful enough to run most of the software. So I'm going to go hunting for Raspberry Pi 02Ws, hopefully. Otherwise, I will see if I can get hold of a Raspberry Pi 3, maybe a 4 if, you know, I'm feeling like splurging, but they're a little more expensive than I want for this project. Anywho, we've got an amplifier that's working. Watch out for the next video. I would suggest subscribing if you want to see that video. If you like this video, yeah, I hope you hit the like button. Thank you for watching. See you next time.